Hello students, now we will discuss IIT problems on electric current. Our problem is a cell is first connected across a resistance R1 and then across resistance R2. Find the internal resistance of the cell such that the power in both the cases is same. That is, find the internal resistance of the cell such that the power in both the cases is same. Now solution is, suppose this is a cell of EMF capital E and internal resistance small r connected with a key K and external resistance capital R across the cell. Now let small r is the internal resistance of the cell, capital E EMF of the cell, and capital R external resistance. When key is closed, see in the diagram, when key K is closed, suppose the current flowing through the circuit is capital I. Current flowing through the circuit is capital I. See in the diagram. Then according to Kirchhoff loop rule, capital I into capital R plus capital I into small r is equal to capital E EMF of the cell applied in the loop. Taking capital I common, we get capital R plus small r into capital I is equal to capital E, or capital I is equal to capital E upon capital R plus small r. Let it be equation number 1. The power P consumed in the external resistance R is given by power P is equal to I square into capital R, or capital P is equal to capital E upon capital R plus small r whole square into capital R. That is, putting the value from equation number 1. Putting the value of capital I from equation number 1, or capital P is equal to E square into capital R upon capital R plus small r whole square. That is by rearranging. Let it be equation number 2. The power P1 consumed in the external resistance R1 is given by P1 is equal to capital E square into capital R1 upon capital R1 plus small r whole square. Let it be equation number 3. Similarly, the power P2 consumed in the external resistance R2 is given by P2 is equal to capital E square into capital R2 upon capital R2 plus small r whole square. Let it be equation number 4. According to given condition, P1 is equal to P2. This we are given. So putting the value from equation number 3 and equation number 4, we get capital E square into capital R1 upon capital R1 plus small r whole square is equal to capital E square into capital R2 upon capital R2 plus small r whole square. Now in both the side, E square and E square cancel each other. So we get R1 upon R1 plus small r whole square is equal to capital R2 upon capital R2 plus small r whole square. Now cross multiplying, so we get R1 into R2 plus small r whole square is equal to R2 into R1 plus small r whole square. Now open the square bracket, we get R1 into R2 square plus small r square plus 2 R2 into small r is equal to R2 into R1 square plus small r square plus 2r1 into small r. Now again open the bracket. So we get r1 into r2 square plus r1 into small r square plus 2 r1 into r2 into small r is equal to r2 into r1 square plus r2 into small r square plus 2 r1 into r2 into small r. Now in both the side 2 r1 into r2 into r cancel each other. So we get r1 into r2 square plus r1 into r square is equal to r2 into r1 square plus r2 into r square, small r square. Now by rearranging, so we get r1 into small r square minus r2 into small r square is equal to r2 into r1 square minus r1 into r2 square. Now taking common from the left hand side, we can take small r square common. So we get capital R1 minus capital R2 into small r square is equal to, in the right hand side, R1 into R2 is common. Within the bracket we get capital R1 minus capital R2. Again in both the sides, capital R1 minus capital R2 cancel each other. So we get small r square is equal to capital R1 into capital R2. Now taking square root both sides, so we get square root of r square is equal to square root of capital R1 into capital R2. In the left hand side, square root cancel with square, so we get small r is equal to square root of capital R1 into capital R2. So this is the value of external resistance if the power in both the resistance is same. So thank you very much.